Today we're looking at similar figures. We know that a ratio is a comparison of two numbers. If we want to write the ratio of A to B, we would possibly write a fraction with A over B, or we might write A and then colon B. These are just different ways to write a ratio. Remember, to be a proper ratio, it needs to be simplified as much as possible. We're going to start by simplifying a ratio here as an example. When you have a ratio, you do need to have the same units. So you're going to have to choose one of these to convert so that you have the same unit of measure. Since 24 inches is exactly 2 feet, I'm going to go ahead and convert that to 2 feet to allow me to have smaller numbers. If it was a different inch amount, like 10 inches or something like that, then I would convert the 4 feet to 48 inches, and I would use my inches as my unit of measure. So we have 4 feet over 2 feet is our ratio. We can reduce this. 4 over 2 reduces to 2 over 1. Since we want it still to be a ratio, you want to write it as 2 over 1, or you can write it as 2 colon 1. If you just write 2, then it's no longer a ratio, and so you do want to write it just like this. There is such a thing called an extended ratio. This is when you have more than two numbers that you are comparing. Remember that a ratio is a simplified version of a comparison of numbers. So if we have an extended ratio, and in this case, these are the angle measures of a triangle, they gave us 3 measurements or 3 numbers in this ratio. And in order to have them represent the angle measures, since the ratio has already been reduced by something that we do not know, what we're going to do is put x on each number. What this will do is will allow the x value to be the amount that it has been reduced by. And we can use what we know about the angle measures of triangles in order to solve for x, and then use x value in order to find each of the original angles by plugging x into 1x, 4x, and 5x. So we know that the measures of the angles of a triangle add to 180. So if we add these measurements together, these expressions that represent each angle, equal to 180, we're able to get 10x equals 180. Dividing by 10, x is 18. So that gives us the value of x, and then if we plug that value into each angle measure here, we will find the measure of each angle. So 1 times 18 is 18, so we'll have 18 degrees. 4 times 18 is 72 degrees, and 5 times 18 is 90 degrees. So our measures of our angles are 18 degrees, 72 degrees, and 90 degrees. A proportion is when you have two ratios equal to each other, such as A over B equal to C over D. In any proportion, you have pieces that are called the means and pieces that are called the extremes. The means would be B and C in this proportion, and the extremes will be the numbers A and D. So you've got your means and your extremes in every proportion. Here I have been given a proportion in segments for this diagram, or lengths of segments. They've told us that JL over LH is equal to JK over KG, and they want us to find JH and JL. So JL, first we need that. We could write it as x minus 2, because x is all the way from J to H, or you could use another letter to represent that piece if you would like. I'm going to use x minus 2. So JL is x minus 2. LH is the bottom of this side of the proportion, so I'm just using this proportion and I'm filling in with the values of each piece. JK is labeled with a 15, and KG is labeled with a 5. So we have a proportion that we're going to solve. You could reduce the fractions in the proportion before you get going. I'm just going to use the numbers as is. We're going to cross multiply. Anytime you have a proportion, we're going to be solving by cross multiplication. I'm going to distribute that 5, and I'm going to continue solving by adding 10 and dividing by 5. and I get the value for x. Remember that x is all the way from j to h. I can deduct 2 from that to get JL, and then we find that JL will be 6. So JL is 6 and JH is 8. Getting our 2 answers we were looking for. We're going to be finding a geometric mean, and when you find a geometric mean, they're going to give you 2 numbers. As we saw in the means and extremes, the means are where I'm putting the x's at, and we're going to be finding the geometric mean. So we're finding the x value. We're going to be plugging in our extremes. And whenever you solve a proportion like this, so we have an example here below this that says 4 and 9, you would put the 4 where the first number is, and then x where the x's are, and then the 9 where the other extreme is at. So we're finding the means, which is to find the x value, and we're doing a geometric mean. And as you solve this in the proportion, you'll see that we're cross multiplying, and we're going to get 36 equals x squared, and to continue solving that, we're going to square root. Now in algebra, when we do this type of solving, we would have a positive and a negative value, but with the geometric mean, we only want the positive value for x. So each time you're finding a geometric mean, what you're going to be doing is you are going to find the square root of the product of those 2 numbers that they gave you. So you can just multiply them and take the square root every time, or you can write the proportion and cross multiply and solve. Either way, you will get the geometric mean. There are certain properties of proportions. One of them that we use a ton, the cross product property. That's why we are allowed to cross multiply and solve when we are solving a proportion. The cross product property states that if your denominators are not 0, then the product of one diagonal, which would be a times d, is equal to the product of the other diagonal, which would be b times c. And here is a numeric example. 2/3 is the same as 4/6. And you can multiply across, giving you 3 times 4, which is 12, and 2 times 6, which is 12. And we can see that these cross products are equal to each other. That is the cross product property. We'll be using that in some of our proofs, and we'll be using it a ton to solve. Now, you can rearrange your proportions in certain ways, and they will remain equivalent. So think of this as like follow the leader. If 2 ratios are equal, then the reciprocals are also equal. So if you look at the left, we have our proportion as is, like at the beginning, and then they have reversed or done the reciprocal of the fraction on the left. So what we have to do is follow their lead. We will do the reciprocal of the fraction on the right, and you can see that the cross products are still a times d and b times c, and so the cross products are still the same, and so these proportions are equivalent. Another thing you can do is interchange the means of a proportion, and so looking at this one, again, this is your given proportion. They have the top from the left over the top from the right. So to follow what they have done, we would have the bottom from the left over the bottom from the right. Again, you still have a times d equals b times c, so your cross product is still the same. Another thing that you can do with proportions is you could add the denominator of the ratio to the numerator, such as they did here. They have a plus b over b. And so if we follow the leader, we can have c plus d over d. So just some different ways you can rewrite proportions. If you have similar polygons, then their corresponding angles will be congruent, and their corresponding sides will be proportional. Anytime you know that you have similar polygons, their angles, their corresponding angles are going to be the same, and their corresponding sides are in a way where you could write a ratio and they would reduce all to the same scale factor, so their corresponding sides are proportional. The scale factor of two similar polygons is the ratio of two of their corresponding sides. So if you know a pair of corresponding sides, you can set them in a ratio and reduce it, and that will give you the scale factor. Just like the sides are reduced to the scale factor, the perimeter also can reduce to equal to the scale factor. So if two polygons are similar, then the ratio of their perimeters is equal to the ratio of their corresponding side lengths. So on the left here we have the ratio of their perimeters, and we could say that that's equal to the ratio of each of their sets of corresponding sides. And any of these ratios will be equal to the scale factor of KLM to PQRS. Corresponding lengths in similar polygons. If two polygons are similar, then the ratio of any two corresponding lengths in the polygons is equal to the scale factor of the similar polygons. If we are given a similarity statement, much like when you had a congruent statement in the previous unit, can use a similarity statement to find all the corresponding pieces of the figures. We can say that their corresponding angles are equal. So we would know that P is congruent to X, that Q is congruent to Y, and that R is congruent to Z based off of the location of the letter in that similarity statement. As far as the sides go, we can write them in a statement of proportionality. There are three sides, so we're going to have three ratios. And the first two letters are PQ. So the first two letters in the next shape, XY, those will be corresponding sides. QR will correspond with YZ, so that's like second, third letter. And then first and last gives us our third segment. And so those are all in a ratio with each other. They will be equal. They will reduce to the scale factor. Here we're going to use a figure in order to identify the scale factor as well as define a missing value. In order to find the scale factor, and they want L, M, and P to be first, and then F, G, H, J to be second, and so your scale factor will be written in this order. First, you need to find a corresponding set of sides and write them in the ratio. So I'm going to use P, N, and J, H from the bottom of these figures. They're oriented the same way where all their corresponding pieces are kind of in the same location. The L, M, and P needs to be the top number because it was written first, and the other shape on the bottom. So we're going to have 12 over 15, which can reduce by 3, giving us 4/5. The scale factor is 4 to 5, and that represents LMNP to FGHJ. In order to use the scale factor to identify a missing variable, we are missing X, which corresponds to the 40. You may set the scale factor equal to the ratio, and in this case, X is from L, M, and P, and that was the top number, so we put that on top, 40 on the bottom, and we can use the scale factor to solve. To use the scale factor to solve, we're going to multiply the cross products. 4 times 40 is 160, and then X times 5, and then divide by 5. That gives us 32 for our X value. So the value of X is 32. I'm about out of time for making this video because the bell is about to ring to release first period. So I'm going to go ahead and push stop here and post what I have, and hopefully I'll get a chance to come back and do these last 3 questions later in a separate video.